right, so today we are going to be taking a look at Module 3, Lesson 1, which has to do with sequences. So the first thing we're going to do is go through and read what we got here in the book here. So it starts off with arithmetic sequences. So this is something that we've talked about in class. An arithmetic sequence is a set of numbers that changes by adding or subtracting, right? So we're always adding or subtracting the term in front of it to get our next term there. So if we're taking a look here, it says, the key to recognizing and describing an arithmetic sequence is to look for a pattern or a common sum or difference from one term of the sequence to the next. So for example, if we have this sequence here, 9, 16, 23, 30, and 37, we want to see what are we doing from each term to get the next one. So to go from 9 to 16, what are we adding or subtracting? So in this case here, we're adding 7 to 9 to get to 16. We want to see if that continues to work. 16 plus 7, right, gets us 23. 23 plus 7 gives us 30, and 30 plus 7 gives us 37. So here, our common difference is going to be a positive 7, because each time we're adding 7 to get to the next term. So if we wanted to continue this to find the sixth term here, right, because here we have a sequence, this is our first term, second term, third term, fourth term, fifth term. To find the sixth term, we would add another 7, and we would see that it's 44. All right, so the sequence forms an arithmetic pattern. The difference between one term and the next is always 7, which is a constant. So to continue the sequence, we keep adding 7. So if we take a look at this sample question down here, it says, if the sequence continues, what will be the seventh term? So here, when we're looking at this sequence, I'm going to write it over here, we have 48, 39, 30, and 21. First thing we notice is that when we go from 48 to 39, our numbers are getting smaller. So if they're getting smaller, that means that our common difference is going to be negative, right? Because we're actually subtracting or adding a negative number to get from our first term to our second term, and so on and so on. So if I want to find the common difference, I take the first two terms. So here we have our first term, 48, our second term, 39, and I subtract the first term from the second term. So I take 39 minus 48. So when we do 39 minus 48, right, we're going to see that we're going to get a negative number here, and it's going to equal negative 9. All right, so from each term here, from 48 to 39, we're subtracting 9 or adding negative 9. From 39 to 30, we subtract 9 or add negative 9. From 30 to 21, again, subtract 9. So now it wants to know the seventh term. So this is our third term, our fourth term. So if we got to go to 7, right, we'll have the fifth, sixth, and seventh term. So to get from our fourth term to our fifth term, again, we subtract 9. 21 minus 9 here is going to be positive 12. To get from our fifth term to our sixth term, again, we continue to subtract 9. 12 minus 9 is going to be 3. And to get to our final term, the seventh term that we want to find, again, we subtract 9. 3 minus 9 is going to be negative 6. So when we're looking here, what is the seventh term? Well, the seventh term is right here, and it wants to know the value of the seventh term, which is negative 6, or choice A. So this one here, we worked out just by creating a list, right, of our terms and subtracting 9 each time. As we go forward, we're going to take a look at the formula we can use to write an explicit formula to be able to find whatever term they ask us, because it wasn't too bad going up to the seventh term, but if they wanted the 100th term, this would really be a pain to go through and keep going all the way up to 100. So if we take it here, describing patterns algebraically. So many numbers sequences can be expressed using algebraic symbols. So if we look again at the sequence that we had at the beginning, 9, 16, 23, 30, 37, we could also describe this using algebra and let the variable n represent any given term number in the sequence, and the number being added to each term is 7. So the first term, 9, is 2 more than this common difference, so the expression 7n plus 2 can be used to find any term in this sequence. So if we wanted to find the first term, we would take this explicit formula, 7n plus 2, and n is our term number. So to find the first term, we'd substitute in 1 for n. So it'd be 7 times 1 plus 2. Then this works out to be 9, which was our first term. So we can use an explicit formula here to be able to do that. We're going to take a look at how to actually find those formulas in a little bit easier way than I think the method they use there. So if we take a look here on the next page, it says, the first term in the sequence below is 6. Which expression can be used to find the nth term in this sequence? So this is where we're going to use our explicit formula. So our explicit formula is going to be a to the n equals a1 plus parentheses n minus 1 times d. Now, we can also write this with an f of n, or an f of x, equals f of 1 plus n minus 1 in parentheses, n minus 1 in parentheses times d. So what we're going through here, some important things to notice are a1 is always our first term. So it's just whatever the value of the first number is here. And then d is our common difference. Right? So this can be a positive number if we're adding each time, or it will be a negative number if we're subtracting. So if we take a look here, from 6 to 1, we're actually subtracting, so our common difference is going to be negative. So if we go through here to write our formula, we have a1, which is equal to the first term here, which is our 6. So a1 equals 6. And then to find our common difference, we take the second term and subtract the first. So we have 1 minus 6. The common difference here is negative 5. So each time we subtract 5 to get to our next term. So now if we want to write our formula, we just substitute in and then simplify. So a of n equals a1, which is 6, plus n minus 1 in parentheses, and then our common difference, which is negative 5. So to remove our parentheses here, we're going to distribute this negative 5 to n and negative 5 to 1, negative 1, and simplify. So a of n equals 6, then negative 5 times n will be plus negative 5n, then negative 5 times negative 1 is plus 5. Now we can go through and collect our like terms. So our only like terms here are our positive 5 and our positive 6. So we can simplify those and we'll be left with a of n equals negative 5n, then 5 and 6. When you add them together, gives us positive 11. So if we're looking for an explicit formula here, right, this is our formula, negative 5n plus 11, that can be used to find any term in the sequence. So if we're looking up here, that's choice C. So if they wanted to know the 100th term in this sequence, we would substitute 100 for n and be able to find it that way. All right, so as we keep going down here, this is just another way that they're showing you this explicit formula. So if we take a look here, it says that a sequence can be written as a comparison of term number and the term or value that results. This is an explicit formula. So we're given this sequence 12, 17, 22, 27, 32. And then we're shown that the first term was 12, the second is 17, third is 22, and so on. And they filled out the table of values below. So formulas define sequences. The notation f of n can be used to describe a sequence where f represents the formula and n represents the term number. And f of n represents the term of the nth number in the sequence. So for example above, if we wanted to know f of 1 just means what is the term value for the first term, which would equal 12. F of 2 is 17, f of 3 is 22, and so on. So f of 4 is 27, and so on. So here, formulas for sequences are useful for finding any term of the sequence. For example, to find the 100th term in a sequence, we would just substitute in 100 for n. So if we had the formula, right, we could find any term. And that's kind of what we did up here with this one, is we wrote our formula so that we could find any term. And here when we have a of n, we can also write this as f of n equals negative 5n plus 11. Right, and then we could substitute in any number for n to find the value. All right, so let's take a look here at the next page. So as we go on here, another method for describing sequences involves comparing the next term with the previous term. So this is called a recursive formula. So the recursive formula is a little bit different. All right, so we're taking a look here. Recursive formula describes the next term in a sequence in relation to the previous term in the sequence. So, for example, if we're taking a look at 5, 8, 11, 14, the value of the next term is equal to the previous term, so 11, then plus 3. So to find the next term, we're just taking the one before it and adding 3. So we always need to know the term before it in order to be able to find the next term in the sequence. So here's a sample question. It says, a sequence of numbers is defined below. So A2 equals 2 times whatever A1 is, and then plus 6. A3 is then 2 times the one before it, A2, plus 6. A4, 2 times A3, which is the one before it, plus 6. So if we wanted to find the value of A5, and we're given that A1 is negative 5, we need to go through using this pattern to find each term before A5 in order to find it here. So we started off with A1, right? They told us A1 is equal to negative 5. So now we can use A1 for the first term and this formula here for A2 to find the second term. So A2 is equal to 2 times A1. Well, A1 is negative 5, then plus 6. So if we're going through here, A2 is equal to, well, 2 times negative 5 is negative 10, plus 6 is negative 4. So now we have our second term. So we have our first term and our second term. Now we need to find A3. So if we look at the formula over here, it says A3 is equal to 2 times the second term plus 6. So A3 is going to be equal to 2 times our second term, which is negative 4, plus 6. So then A3 equals, well, 2 times negative 4 is negative 8, plus 6 is negative 2. So now we found the second term, or the third term, sorry. So now we're going to use that to find the fourth term. So again, we look at A4 is equal to, over here it says 2 times A3. So 2 times then A3 is negative 2, plus 6. So A4 is equal to 2 times negative 2, which is negative 4, plus 6, positive 2. So now we have A4, and we can finally use A4 to find A5. So we have A5 is equal to 2 times our value of A4, which is 2, then plus 6. So A5 equals 2 times 2, which is 4, plus 6 is 10. And that finally answers our question, what is the value of A5? So in order to find A5, right, we couldn't just substitute in our formula 5 for n. We had to go through and find each term before it using the recursive sequence there. So now if we take a look down here, it says, in the sequence below, A1 equals 1, and the value of A2 equals 2. Which rule best describes how to find the value of A50? So here we're looking to see what's happening. Well, to get from 1 to 2, we add 1. To get from 2 to 3, we add 1. But to get from 3 to 5, we don't add 1, we have to add 2 here. So if you keep looking for a pattern here, you'll find out that here, right, we have term 1, term 2, term 3, 4, 5, and 6. In order to get the term that you're looking for here, so say term 6, we have to add together the values of terms 5 and 4. So if we wanted to find term 6, so A of 6, we would add together A4 plus A5. So to show this here, right, A6 was 13. If we add together A4, which is equal to 5, plus A5, which is equal to 8, you'll see that 13 equals 13. So if we're trying to find the value of A50, if we look at this logic here, well, we have to add together the two that come before 50. So the terms that would come before 50 would be A48 plus A49. Those would be the two terms that come before 50, which here is choice D. So that would be the sequence here that we would use to find the 50th term. So again, it's using the terms before the term you're looking for to find the term you're looking for. So now we're going to take a look at the practice problems. So starting with practice problem 1, it says which expression represents this sequence algebraically. So this is where we're going to use our formula, right? A of n equals A1 plus n minus 1 times D. And then we need to identify our first term. So if we look here, the first term is 8. So we know A1 equals 8. And then we need to find our common difference. To find the common difference, we take the second term and subtract the first term. So 17 minus 8. And if we go through here, 17 minus 8, we'll see that it is 9. So our common difference each time, we're adding 9. So now we're just going to substitute into our formula here, right? So we have an equals our first term, 8, plus parentheses n minus 1 times 9, which is our common difference. We're going to simplify by distributing that 9. So we'll have 8n equals 8 plus 9 times n, 9n, 9 times negative 1, negative 9. And then add our like terms, which if we take a look here, right, our like terms are negative 9 and 8. So we can write our 9n first, and then 8 minus 9 is going to be negative 1. So if we're looking at our answers, 9n minus 1 is choice D. And remember, this is a formula now that could be used to find any value in this sequence here. All right, the next one here, question 2 says, the expression 12x plus 6 can be used to describe a sequence algebraically. Which sequence could be the first 5 numbers in this sequence? So again, they gave us this formula, right? 12x plus 6. X here is going to be the term. So if we want to find the value of the first term, we're going to substitute in 1, which is the first term, for x, right? So if we wanted to write this as a formula, we could say this is f of x equals 12x plus 6. So if we want f of 1, we'll do 12 times 1 plus 6. If we work this out here, 12 times 1 plus 6 is going to be 18. So our first term, right, is 18. Now, if we want to find the second term, we take that same formula and we substitute in 2. So f of 2 equals 12 times 2 plus 6. 12 times 2 is 24. 24 plus 6 is 30. So our second term is 30. So right away, we can see that our answer is going to be choice C here, right? Because that's the only one that starts with 18 and then 30. But let's pick just another one in here. Let's go for the 5th term and make sure it adds up to 66 here. So if we take f of 5 equals 12 times 5 plus 6. Well, 12 times 5 is 60, plus 6 is 66. So if we take a look here, our 5th term, right, which if we're counting along here, we have term 1, 2, 3, 4, 5. Our 5th term was 66. So C is definitely our answer there. So again, we were given the formula, and then to find each term, we just substitute in whatever term number we're looking for a variable x there. All right, this next one says the first term in a sequence is negative 13. So here we know the first term is negative 13. The common difference between terms is negative 4. What is the 7th term in this sequence? So 2 ways we could go about this problem here, right? This one we could say we're doing a sequence. Negative 13 is our first one. Each time this is our first term, we want to find our 7th term. We know that the common difference is negative 4, so we could just subtract 4 each time. So 13 minus 4 is going to be negative 17. And we can keep going, negative 21. So this is our first term, second, third, fourth, fifth, and we'll go sixth and seventh. So then negative 21 minus 4 is negative 25. Negative 25 minus 4, negative 29. And we keep going, negative 29 minus 4 is negative 33. And then we take a look here, 3, negative 33 minus 4 is negative 37. So this was one way to do it because it was the seventh term. So we'd see that it is equal to negative 37. Another way would be to write our formula, right? So we have a of n equals a1 plus n minus 1 times d. So if we want to find a of 7, right? So a7, we could go through here and fill in this formula. So a1, right, was negative 13 because that was our first term, plus n here is 7 minus 1 times our common difference of negative 4. So if we go through here, a of 7 equals, well, negative 13. Then we have 7 minus 1, which is 6, times negative 4 is going to be 6 times negative 4 is negative 24. So if we have a of 7, negative 13 minus 24 is negative 37. So again, using our formula, we can find this by substituting in 7 for n, substituting in our first term, which was a1, which is negative 13, and our common difference, which is negative 4 for d, and then simplifying the equation there to find that a of 7 is equal to negative 37. All right, so if we take a look, there's 2 more multiple choice questions. So we flip over to the next page. It says the table below shows how the amount remaining to pay on an automobile loan is changing over time. So if you take a look here, it says the auto loan payoff time, and it goes from 0 months all the way to 4, and then the amount remaining dollars. So right when you buy it, right, it is $5,000, and then each month it's going down, right, which makes sense because you're paying off your loan. Let n represent the time in months, and let f of n represent the amount in dollars remaining to pay. Which equation describes the relationship between n and f of n? So what we really want to look for here is see what is our common difference, right? Because our common difference is going to be multiplied with our variable n. So if we're looking from 500 to 4,800, right? If we want to find the common difference, we take 4,800 and we subtract from it 5,000. And you'll see that our common difference here is negative 200. So every single month, we're taking away 200. So negative 200 is going to be multiplied with our variable. If we're looking at our different choices here, it's just choice B is the only one that has negative 200 attached to the variable. So this shows that each month, right, you're paying 200 off of that original 5,000. So choice B is our answer there. The next one here, the first 5 terms in a sequence, or the first term in a sequence, A1, is 2. Each term following is 3 less than half the previous term as shown by the equation below. So here we have a recursive series because we need to use the previous term in order to find the new term. So if we wanted to find A4, we're going to have to go through and find each term in between A1 and A4 in order to work this out here. So we start with A1 is equal to 2. That's a good one. We already know it. Now to find A2, we're using this formula. So it's A2 equals 1/2 of A, and then we have 2 minus 1 minus 3. So when we're going through here, this 2 minus 1 really simplifies to A2 equals 1/2 of A, and 2 minus 1 is 1 minus 3, which means that we're just taking the term before it, A1, and substituting that in there. So A2 equals 1/2, then A1, which is 2, minus 3. So A2 equals 1/2 of 2 is 1, then minus 3, 1 minus 3 is negative 2, So A2 equals -2. So now we have to go along and find A3. So to find A3, we're going to take 1/2, then we're going to take 1/2 of the term before it, which is A2, which is -2, and then we're going to subtract 3. So A3 equals, well, 1/2 of -2 is -1 minus 3. A3 equals -1 minus 3, which is -4. Then to find our last term, the one we're looking for, A4, we're going to take 1/2, multiply it by our term before, which is -4, and then subtract 3. So A4 equals 1/2 of -4, which is -2, and then subtract 3 minus 3. So A4 equals -5, which is choice B. So we're using the term before it, right? So here we used A3 to find A4. We used A2 to find A3, and then we used A1 to find A2. So we're constantly using the term before it to find it. And that's a recursive series. All right, so now we're taking a look at the last problem here, problem number 6, and it says, the table below shows the number of horse races won each year by a jockey. So the first year, the jockey won 0 races. The second year, they won 3. The third year, they won 6. The fourth year, they won 9. And the fifth year, they won 12. So if this pattern continues, how many races will the jockey win in year 8? So if we're going through here, we can see that each year, right, the wins are increasing by 3. So from 0 to 3, we added 3. From 3 to 6, we add 3. 6 to 9, add 3. 9 to 12, add 3. So if we wanted to just use this pattern and have it continue, right, we can just make our table continue with 6, 7, and 8. And we could say that to get year 6 wins, we'll take 12 plus 3, which is 15. To get year 7 wins, we take 15 plus 3, which will be 18. And to get year 8 wins, we take 18 plus 3, which will be 21. So in year 8, the jockey will win 21, right, races won. Now it says write a formula using f of n that can be used to find the number of races the jockey will win in year n if this pattern continues. So for a formula, we're simply writing f of n equals f of 1, or how many they won in the first year, plus n minus 1, parentheses, times the common difference. So now we can fill this in here. F of n equals, well, in year 1, they won 0 races, so put in 0, plus n minus 1 times our common difference, which is 3. Each year goes up by 3. So now to simplify this, we'll take our 3 and distribute it to both n and -1. So if we're going down here, f of n equals, well, our 0 can kind of disappear now. So we have 3 times n, which is 3n, then 3 times -1, which is -3. And the formula that you could use to find any number of races they'll win if we use this pattern, and this pattern continues, is f of n equals 3n minus 3. All right, so this is it for lesson 1, and take a look out for lesson 2 coming soon.